C3. The atomic number of americium 241 is 95. Americium 241 decays by losing an alpha particle. A1. Explain why smoke detectors containing americium 241 are not harmful to people. So, they are not harmful to people because americium, it is emitting an alpha particle which has a very short range in air. Therefore, it cannot penetrate the human skin. It cannot even penetrate a sheet of what? Paper. So therefore, it is not harmful because it has a short range. So remember that alpha particle is stopped by a paper or even the skin or even the cloth. So part 2, copy and complete the equation showing this decay by giving values for x and y. Okay, so this is alpha decay. So remember that this one, it is emitting an alpha particle. So the mass number, it will be reduced by 4. Okay, so we are going to have 237. So 241 minus 4, it is 237. Then the proton number, it will be reduced by 2. So we are going to have 93. So that is the way it is. So the value for X is 237 and the value for Y, it is 93. So part B, figure C 3.1 shows how the activity of a sample of americium 241 changes over a long period of time. So this is time in years, this is activity counts per minute. So part 1, use these numbers to draw a graph of activity against time for americium 241. So the first thing is that you need to come up with a suitable range. So as you can see for time, which is the x-axis, so against time. So time it is x-axis, activity it is y-axis. So for x-axis we have 0 to 2000. So we have to choose a suitable range. Then there we have 2 to 64. So that is for the y-axis. So for the x-axis, I'll take 2 centimeters to 250. Then for the y-axis, I'll get 2 centimeters to 10 units. So you have to label the x-axis time in years. So we have 2 centimeters to 250. So that is for the x-axis. So from here to there, so how do we count? So we count 1, 2, 3, 4. That is 100. 1, 2, 3, 4. That is 200. 1, 2. That is 50. So we have 250. So 1, 2, 3, 4. 350. 1, 2, 3, 4. 450. 1, 2. 500. Then we have 10, 20, 30, 40, 50, 60, 70. So for the y-axis, it is activity, so counts per minute. So from there now, I'm going to plot. So remember, you always start with the x-axis, you end with y. So x, we have 0, then y, we have 64. So 0, 64. So 0, 60. So 61, 62, 63, 64. So you have to use a pencil. So that is 64. So you have to use a pencil. Then we have 500, 30. So 500, 30. So this is 500, 30. And then we have 1000, 14. So 1000, 10, 11, 12, 13, 14. Then we have 1500, 6. So 1500, 1, 2, 3, 4, 5, 6. Then the last one is we have 2000, 2. So 2000, 1, 2. So our graph will move from here, it comes here, then it will end there. So you have to use a freehand. So this is the graph that we have. Okay. So the next question is, use your graph to find the half-life of. Do we use our graph to find the half-life? So now remember the total activity, it is 64. So we are going to find the half of 64. So half of 64 is equal to 32. So we'll go on the graph where 32 is. So this is 30, 31, 32. So this is 32. I'll draw a dotted. Then from where the graph is intersecting with the line, I'll come downwards. So this is where it is intersecting. So this is where the answer will come from. So this is 250. So this is 250. 1, 2, 3, 4. 350. 1, 2, 3, 4. 450. So 450 years is the answer. So remember the range that we are taking here. So it is these small boxes, 1, 2, 3, 4. That is 100. 1, 2, 3, 4. 1, 2, 3, 4. That is 100. 1, 2, 3, 4. That is 200. Okay, so this is 250. So 250 we have 1, 2, 3, 4. 350. 1, 2, 3, 4. 450. So 450 years is the half-life. So the half-life, it is 450 years. And part C, Californium-241 is also radioactive and decays by losing an alpha particle. Its half-life of 4 minutes suggests why it should be unsuitable for use in a smoke detector. So Californium-241 is unsuitable for the use in a smoke detector because it has a short half-life of 4 minutes. So which makes it unsuitable for smoke detectors because it decays very quickly. So smoke detector would stop functioning within a very short period of time.